Okay, so if R4 is large, the key thing that's going to happen is you're going to get much less voltage drop here. Okay? Because you got a much bigger voltage in this loop, so you got much less current. So you're going to have much less current going this way, right? Now what that's going to do, if you've got 3 volts here and 2.4 volts here, which follow directly from the assumptions we're working on, that's going to reverse the direction of both of these currents, right? Okay? So for an example, we say, okay, let's just say that this is 50 ohms, so you got a 1/10 of an amp here, so you got a 1 volt drop. Okay? Now we start with the 1 volt drop, but it takes 50 ohms here to do that. You should confirm that. I think you can. You can probably do that in your head. If we got a 1 volt drop here then, 3 volts in this direction, that's going to start causing problems because that's going to reverse the current. Okay? If you got a 1 volt drop here, 3 volts here, you're going to have 2 volts in this direction through R2, or in the direction that we've been talking about, a negative 2 volt drop here. But that's going to make I2 negative. Direction opposite we have, so it's going to be this way, right? And similarly, this one's going to go this way. This only has 2.4 volt drop according to our assumptions, right? So we have a net 3.6 volts. 2.4, that's not 6 anymore, it's 1. Yeah, I'm sorry, 1.4 volts back this way, right? Okay? And if these are all, say, these 3 are all 10 ohms, that's going to get 0.14 amps in this direction. Now if you just add those up, well, you're going to have a current in this direction and a current in this direction. They join up here and flow into this, right? So you're going to have, what did we say? You're going to have 0.2 and 0.14, 0.34 ohms coming in here. 0.34 ohms, 34 amps coming in here. Okay? You've got a 1/10 of an amp going out, and you got something coming in from R4. It doesn't balance. Okay? Which means that the assumptions we made are not compatible with the new circuit, right? Assumptions we made could be compatible to, yeah, they're perfectly okay if you don't have a resistor here. And they keep working until these currents start reversing. Okay? Maybe. But maybe they don't work at all. I'll let you figure that out. Okay? So we're playing around with parameters. We're playing around with the circuit because what do you do when you're designing something? You play around with possibilities. Okay? Okay, so a large R4 implies small I1 implies small voltage drops. That better be specific across the parallel components.
Better, and that's what they told me to go on.
With our assumptions,
Oh, good. Yeah, that's good.
This reverses I2 and I3.
Bye.
And lead to contradictions. Okay? Make sense? And you can reduce the whole thing to absurdity. And if you let R4 approach infinity, well, now that's a little harder to reason out. I don't want to lay that on you. Okay?
Right.
You can think about it if you like. I'll just say that in the example that we use, if R4 is 50 ohms, then I1 equals 0.1 amp. It isn't. 0.1. Yeah, it is. Okay. Because the current through the loop, 60 ohms, 6 volts. It's 0.1 amp.
We pretty much moved in with him at this point, so. Wow, that's so exciting.
The voltage drop is 1 volt. And without going into detail, you get 1 volt from here to here, but 3 volts here means that you're going to have 2 volts here, but in this direction. I2 in the direction we say is negative 0.2 amps. And I1 is negative 0.14 amps.
Sometimes I'll just sit there and cry while she's crying.
Right?
And nothing helps. No, it's understandable.
So,
Wait a second, I thought I1 was 0.1.
Yeah. Because for a little bit, we had a.
No.
what now?
I1's 0.1, right, not negative 0.14?
Oh.
That's I'm sorry, I wrote I1 and I3.
Oh, okay.
Okay. First node,
No, we switched back to the 7. She's doing perfectly.
won't balance. That is, you're going to get accumulation of charge at the first node, and you can't have that.
Thank you.
Okay?
Yes. We're just sitting there crying together.
So our assumptions clearly don't work if R4 is large enough, because if R4 is large enough, these two currents reverse and give you contradiction at this node. And we'll just call this the first node. And we don't need any more nodes. Okay? So small R4, no problem, small change. But at the threshold, when your voltage drop here drops below 3 volts, things start to get funny. Now it still might work out with a 3 volt drop here because I3 will still be in this direction and maybe they'll balance, but I doubt it. Okay? Okay, make somewhat sense?
Yeah.
Again, we're talking about conceptually. You can set up the differential equations and solve them.
Right.
Or you know that they can be set up and solved. Okay? Give any reasonable source function here, and you can figure out what's going to happen in the circuit. Okay, this is your input. So you get a bunch of non-homogeneous equations. Okay? And if you wish, I1, I2, and I3. Okay. Well, that's what we've got. Now, what would be the effect of putting an R4 in here and then an R5 here? Okay, could that?
That would affect the negative 2 volts, wouldn't it? It wouldn't be negative 2 volts anymore.
Right.
That would be in loop 2.
Well, you wouldn't have equal voltage drops across all 3, but you would still have equal voltage drops across these 2, right?
Right.
So if I put the right resistor in here with a relatively large R4, can I put a resistor in here that will make this thing at least consistent? I'm not asking you to solve for it, but what happens if I put a little resistor in here? What happens if I put a bigger resistor in here? What happens to these currents? Do they still reverse?
And you're talking about across the top, right?
And yeah, and if they still reverse, could the reversal be small enough that you get a balance here? Okay?